Hello, my name is Larry Onajaka. This is my presentation for System Dynamics and Control. First, we define System Dynamics and Control. System Dynamics and Control is a way for us to model mechanical systems and convert moved motions of mechanical systems into mathematical equations, which then allows us to study the motion. By studying the motion, we're able to predict and have different aspects of the motion that we can focus on in order to optimize the system. In system dynamics and control, we usually have an input. And the inputs goes through a series and they produce an output. Now, what's very important in this is that sometimes our input is different. When we get on the output, we have our desired output. So when we do not achieve our desired output, we create a loop that goes back, and this loop is meant to adjust the input. So in a very simple way, this is the concept of system dynamics. We're trying to figure out what do we need to do to get our desired output. Now, this class breaks down into two sections: the system dynamics and the control. The system dynamics is the approach that comprehends the behavior of a complex system utilizing flows, feedback loops, and functions and time delay, which is what we have depicted here. Whereas control focuses on the aspect that's operating the system. So here, this entire thing will be considered system dynamics. Whereas the concept inside this box, there's a controller. The controller is what received this message. The controller is what's receiving this message, and then the controller is what's responding by adjusting the input. This particular project, I'm going to focus on modeling the mechanical system of a car suspension. When we think about a car suspension, what we have here is a very simple form of a car suspension system. Where here you have the mass of the car, 1/4, because recall the car has 4 wheels. 1/4 mass of the car. Here you have stiffness due to the suspension system and friction, which here is denoted as a damper. And then here you'll have the mass of the entire suspension system. Plus the wheels or anything else that's attached that's being compressed. So this part of the mass is uncompressed, and this part of the mass is compressed by a spring. And here we represent the tire. So this section represents the stiffness of the tire as well as the friction due to the tire. And when you model a system like this, you have to consider 3 things. One, you have to look at the potential energy. You have to look at the kinetic energy. And this combination of these two will result in some constant. When you go to take the time derivative of this entire thing, you will end up with a differential equation. Now, in some cases, you'll have a differential equation that's a homogeneous equation. For this particular case, because you're going to always have an external force, the differential equation is not going to equal to 0. Once we achieve the mathematical equation that represents this motion, we've got to do several things. We have to now take the Laplace transformation to get it in the S domain, and then we'll also do the inverse Laplace to get it in the time domain. The whole purpose of this is to eventually derive an equation that defines position of our masses with respect to time. Or we can also derive an equation that defines the velocity of our masses with respect to time. Why is this important? This would allow us to know what aspect of our design we would need to tweak to achieve the desired velocity or the desired position. So for example, if I want to make sure that my car is balanced, but I don't want this mass to either go too low or too high, I have to make sure that I distribute the weight on my car accordingly just to meet the desired output. So the purpose of this is to design a system, model the system, and then run simulations on the system to be able to make your optimization and make sure you have the most efficient system. This is my first presentation of modeling mechanical systems, and on my final project, I would go ahead and work this out so you can see how when we change the mass of either of these components, how it would affect the system, or if we change the stiffness or the damper, how would that affect the system, and so far on. Thank you.